Okay, so this is the follow-up video going over the code implementation for my heart rate project. If you haven't seen the first video yet, you should go check that out because it'll give you a better understanding of what's going on and why some of this is written as it is. So this initial comment box just initializes the Arduino and tells Unreal to read the serial port with which the Arduino is sending data over. That data is stored as 4 bytes or sent over as a series of 4 bytes and converted from that to an integer which Unreal stores as your current BPM. After initializing the Arduino setup and confirming that it is good to go, it prompts success, and then it initializes the UI in the screen. So the UI demonstrates what music is currently playing, your current heart rate in the corner, and whether your heart rate is over 100, under 65, or being artificially incremented by an additional factor. On tick, it checks to see that the Arduino is still valid and initialized, and then it reads the serial data and converts it to an integer, which is stored as your current BPM. From there, it checks to see if the BPM is being artificially increased. If it is, it goes up to this upper row. And in this upper row, it stores the artificially increased BPM as the BPM in the UI, but not as the current BPM in the game. And the reason for that is because the artificial BPM is dependent on your current BPM and is variable on it so that you get a smooth transition. If it weren't that way, then you would undergo a rapid series of increase because the artificial BPM would be based upon itself and increment based on itself. So it would just continue to rise forever. So not good. The UI is then set up so that the minus and the plus are disabled and the text is set as green. If the BPM is not being artificially incremented, then it checks to see if it's over 100 or less than 65. If it is over 100, it sets it as 100. And if it's less than 65, it sets it as 65. And the reason for that is because the parameters inside of FMOD Studio are in a 65 to 100 BPM range. This can be pretty easily changed, but it was set this way so that I didn't have to write too many pieces of music. There's already 35, one for each individual heartbeat. So doing any more than that was kind of excessive given that my resting heart rate is generally within that range. From there, it sets the UI to red if your heart rate is over 100 or under 65, and adds a plus or a minus. And then if your current heart rate is between 65 and 100, it stays white and disables the plus and minus visibility. Then we'll go over to the FMOD implementation. So when you enter each new area, so for example, the area where just your heartbeat is playing, it checks to see if there is currently an audio track playing. And the reason for that is if you were to overlap and re-overlap the trigger, then it would just continue to add on additional instances of the FMOD component and play that over and over, which is not good. That would get cluttered pretty quickly. So then it adds the FMOD component for the heartbeat. In this example, it plays it, sets the UI, and then sets this variable for is playing so that you don't get the overlaps. And that's generally the same exact setup across the board for the heartbeat, the parameterized music, and the procedural music. Then the interesting part is the on-tick, which sets the parameter for each one to your current BPM in all cases except for the artificially incremented one. In the case of the artificially incremented music, it sets the parameter for your current heart rate to the sum of your current BPM, which is over here, plus the distance between you and the target point, and interpolated to be a reasonable value, and stores that new variable as the artificial BPM, which we saw earlier. Sets to mark that audio is playing, and then it also sets the UI, which controls this check over here to see whether artificial heart rate is being incremented. And the only other thing going on here is the main area of the level cuts all of the other music that is being played and sets the UI as inactive. Now I will go over the FMOD project. Okay, so for the FMOD project, I'll quickly go over the early implementation of the heartbeat system, why that was flawed, and then go over the new heartbeat system, why that works better, and the procedural music system. So in the old version of the heart rate system, which is currently marked as heartbeat, not heartbeat v2, you can see that if your heartbeat is, say, 70, for instance, it'll play that and loop it. But if your heartbeat ever changes to something else, which I've set to 74 using the parameter circle in the upper area of the screen, you get a doubling effect. And that doubling effect occurs because when you switch to the new heartbeat sound, it plays on the switch and it continues to play out the rest of the previous file. And there were a few ways to go about correcting this error, but one of the biggest problems is that FMOD doesn't store the value between where the current playhead is in an audio file and the end of the playhead, so setting a delay in Unreal didn't work out. However, there is a workaround for this, and that uses the transition marker system within FMOD. So if you're familiar with the way transition markers work, is for every transition marker, you can set a destination region elsewhere in the file. So at the end of the 65 BPM heartbeat sound, there's a transition marker to every other potential BPM for your heart rate. And that new heart rate is marked with a destination marker. And that is the case for every permutation and combination of heart rates possible. So if you scroll across, you'll see a giant wall of transition markers all the way down for every possible heart rate value. But the benefit to the system is now it won't transition to the new heart rate until it's finished playing out the previous file. So to demo this, you can see it'll play the 70 BPM one, and if we switch it to, say, 74, it finishes playing out the previous one and transitions smoothly to 74. That's the same exact setup for the procedural music system. It just finishes playing out the procedural track, or finish playing the current track. Lower the volume on it real quick. And the only other thing is the parameterized music. So for that, you'll see that we have a much more normal looking track going on. There is the instruments involved. You've got keys, low strings, violins, and percussion. But the parameter in the dial is set to BPM 2, which is slightly different. It has a larger range, but other than that, works relatively the same. So when your BPM is low, you just have the keys playing, and I'll show that based on the volume of the other tracks. So as your heart rate increases, you can see the volume of the low strings increases. And further, you add the high strings. And further, you add the percussion. All right, that's just about it for this project. If you're interested in seeing some of the Arduino code, I've got a previous video that covers a bit of that. And let me know if you have any questions about how all of this works. Thanks.